Now that you've learned some of the basics of quadratic functions and what they look like, in this video we're going to learn about quadratic regression. Sometimes in practical settings, we have a set of data that appears to have a maximum or a minimum. The tools that we've learned so far, using linear, exponential, and logarithmic functions to fit data, so these were linear regression, exponential regression, and logarithmic regression. Those are not going to be appropriate for this kind of data because those kinds of functions don't have a maximum or a min. So a linear function obviously was just a smooth line. An exponential function is always increasing or decreasing, but more has a curve instead of flat. And logarithms are similar to exponential functions. So instead of using those functions to fit data that appears to have a maximum or a minimum, we can use the quadratic functions that we saw in the previous video. So let's take a look at some data from your textbook. And this was example 516, if you want to take a look at it. So what we're looking at in our data is a year, and then the numbers of ospreys fledged by a conservation group in that year. So in 1992, there were 8 ospreys fledged. So an osprey is a bird of prey, if you're not familiar with them. So the conservation group raised and released 8 ospreys in 1992, and then in 1993, that number went up to 18. In 1994, it was again 18, but in 1995, it went down to 7. So in our data, we see a peak in these 2 years. So that means we need a kind of function, like a quadratic function, to fit the data that has a peak or a minimum. So let's head over to Desmos and see how quadratic regression works in practice. So here in the table, I've entered the data, and you should notice that I've used 0 for the year 1992, and then 1 for 1 year after 1992, so that's 1993, and then 94 and 95. And then over in the graph, we can see our points in black, and we can see that the data appears to have a peak, so it's going up, and then it has a peak maybe somewhere in here, and then it starts going down. So now let's do our quadratic regression. So this is going to appear much the same way that linear regression and exponential regression looked. We're going to type y1, so that corresponds to the column for y, and then we'll use a tilde, and then we'll type out a x1 squared plus b x1 squared plus c. So what we've typed out here looks very similar to the quadratic function formula that you saw in the previous video, but I've replaced the equal sign with a tilde, and instead of using x and y, I'm using y1 since this column has y1, and I'm using x1 since the first column is labeled x1. But then we still have the a times x1 squared and a b times x1, and we don't need a square there. Get rid of that box. There we go. It's fixed. And now that we've made that fix, we can see the graph as it should appear. So we can see our data points, and then this parabola that we created using Desmos. And we can see that it closely matches the data, not perfectly. This data point is maybe just a little bit above. That one's a little bit below, above again. And then this fourth point looks pretty much right on. But it's close to our data set, and that's what matters. And here at the top, we can see the maximum is already labeled for us. And over on the left, underneath where we typed the formula for regression, we can see the parameters that Desmos has found. So these are the values for A, the coefficient on x1 squared, B, the coefficient on x1, and C, the constant at the end. So in this case, A is minus 5.25, B is 15.45, and C is 7.95. So there's a few things that we can do now that we have this regression, this quadratic regression. For example, we could predict what might have happened in 1996. We could predict the number of ospreys fledged. So 1996 is where x is equal to 4, and we can see what happens. So you'll have to type in y equals, and then plug in the values for A, B, and C. So minus 5.25. And then we'll plug in 4 for 1996. Okay, and then B is 15.45. And again, we'll plug in 4 for 1996. And then we'll add the value for C, 7.95. And we've run into a problem because the answer that we're getting is minus 14.25. And over here on the graph, we can see that it's dipped way down here somewhere. So what this means is that our quadratic regression doesn't really make any sense after this point because, well, it doesn't make any sense to have a negative number of birds that you're releasing in the wild. So if we're going to use this quadratic regression, we're going to have to look at things here where the graph is positive. So that's between the two x-intercepts, the two zeros.